Before we go on, I would like to talk a little bit about how someone could be misleading using a correlation study or an experimental study. Okay, so I have an example here of, this is an actual example of someone who used a correlation study in a misleading way. It came from an editorial in the Washington Post. A columnist or a person, I'm not sure who it was, George Will, wrote the following in the Washington Post in 1993. Basically, the 10 states with the lowest per pupil spending included 4 states: North Dakota, South Dakota, Tennessee, and Utah. And among the 10 states with the top, they were among the 10 states with the top SAT scores. New Jersey, which has the highest per pupil expenditure, an astonishing $10,561. And what was its rank in SAT scores? They were 39th. Okay? So basically this article is saying, okay, spending more money per pupil is not necessarily increasing the SAT scores for our students. And so maybe we don't need to be spending so much money. Maybe, in fact, it could, spending more money per pupil might have a negative effect on their learning, on their SAT scores in this case. And in fact, here's a scatter plot this is the data. And what a scatter plot is, we haven't talked about them yet, but we'll talk more about them in Chapter 2 here, this is the spending per pupil, and this is their SAT score. And so what you see, there's at least a general trend of, as you increase the spending per pupil, it seems at least overall the SAT score is going down. Okay? So it's almost as if spending more causes the SAT score to go down. And in fact, that's the point that this columnist was saying, that we don't necessarily need to be spending more per pupil. Their SAT scores, in fact, are going down. So this seems like good evidence for what the point that this columnist was trying to make. This here is just showing that North Dakota, which was the 45th in spending, meaning they were way down there. Only 5 states spent less than North Dakota. They had very high, well, above average SAT scores, while in New Jersey, which was the second highest in spending, you can see that their SAT scores were just a little below, a little above average, but weren't significant here. So all of this here really seems to lead someone to the conclusion that we don't necessarily need to be spending more money. Okay, it's not going to affect students' scores. Okay, but that's not what is going on here. And so this person is using this correlation study, this observational study, in a misleading way. And he may not have realized that he was doing this. Okay, but what he should have known is that a correlation does not prove causation. That is a very important thing to remember. So one thing to go away from this class remembering is just that a correlation between 2 variables does not mean that there's a cause and effect relationship between the variables. Correlation does not prove causation. It could be a cause and effect relationship, but it doesn't have to be. There could be another explanation. And indeed, in this case, there is another explanation. And what that explanation is this, that the states here that didn't spend as much money did not have very many students taking the SATs. Think about Iowa, for example. In Iowa, we don't take the SATs, we take the ACTs, right? There's not very many of us that take the SATs, and if there are, they are probably some of the higher ranking students who are planning on going to the West or the East Coast to attend college, maybe at like an Ivy League school. Okay, so what you're doing here is, in New Jersey, everybody takes the SATs because that's the test that they take. and you're comparing your average student in New Jersey, okay, to the cream of the crop in North Dakota. Okay, I think, and I don't have the data here, but I think only the participation rate in North Dakota was 5% of the students took the SATs, while in New Jersey it was like 78% of the students. So really, all you're doing is comparing the cream of the crop in North Dakota to your average student in New Jersey, and of course, you get this sort of relationship. So yes, there is a correlation between the variables. As the amount of spending goes up, the SAT scores go down, but there's other explanations for that relationship. Okay? And in particular, the places where there's a higher standard of living on the West and the East Coast, where they have to spend more money per pupil, those are the places where everybody takes the SATs. Okay? And the places that don't need to spend as much per pupil, okay, in those places, not as many people take the SATs. Only the cream of the crop do. Really, really nice example here of how someone might use a correlation study to make a point when really it's misleading. The correlation study does not show cause and effect relationships. Okay, well, what about an experimental study? Okay, let me give you another example here. I just had it. Here it is. So this is the example that we looked at, the two teaching methods. Okay, and this is an example I really like because it kind of, it shows how everything fits together. An experimental study, here's descriptive statistics. So the two samples, we're taking the reading scores for those that are taught by method A and the reading scores for those taught by method B. And it seems like method A has higher reading scores. Okay? So we do see that the people that were taught by method A did do better than those that were taught by method B. Okay, so the way that this could be misleading, though, okay, is that if someone used this study to show that method A was better, when in fact the difference here could have been due to just chance. So in other words, if you were to do the inferential statistics and actually look in depth at the probability, the mathematics, you would conclude that really, even though there's a difference here, it's not a statistically significant difference. So a statistically significant difference is one where the difference is more than you would expect due to just sampling error. Okay? If this difference was not statistically significant, and someone used this study to say, hey, those taught by method A did better, you should use method A, that would be misleading because the difference could have been due to just sampling error. Does that make sense? So another way statistics can be misleading is if somebody uses an experimental study to show a difference between two groups, but the difference isn't statistically significant, and they fail to mention that fact. There is a difference, but there's always unless they're exactly the same, there's going to be a difference. The question is whether the difference is large enough to say that it was statistically significant and it was due to more than just sampling error. Okay, so those are things to look out for. If you're reading an article and someone is using a correlation study to prove their point, you need to ask yourself, are they assuming that there's a cause and effect relationship between these variables just because there's a correlation between them? And if they are, do they have an experimental study that actually backs up what they're saying? Because they would need an experimental study to provide evidence for a cause and effect relationship. The correlation study just suggests that it might be, but it's not evidence that it is. There could be other relationships that cause the correlation. Okay? And then if you see an experimental study, someone quotes an experimental study and the difference between the groups, you need to ask yourself, well, was the difference statistically significant? Was it big enough to say that it was due to more than just sampling error? Okay, and that's what you want to be aware of. Okay, and of course, the other way statistics can be misleading that we talked about earlier was the biased sample. So was these samples randomly selected, or did they put smarter students in sample A and not as smart as students in sample B to make this group look better? Okay, maybe a company does that to make their product look better. That's another thing to be aware of, the biased sample. These are all ways that statistics can be misleading and things that you want to be aware of. You don't want to be cynical, because when statistics is used right, it is helpful. It is a useful tool, but you do want to be critical. You want to know ways that it can be misleading. And the biased sample is one way. The correlation being used to show cause and effect relationships is another way, and an experimental study where they quote the difference even though the difference is not statistically significant. Okay, those are all possible ways that statistics can be misleading.